So next is multiplication of factors. The criteria A is the number of columns of the first should be equal to rows of the second. So suppose there are two vectors. The number of columns of the first vector should be equal to the number of rows of the second vector. Only then multiplication is possible. Then two rows or two columns cannot be multiplied. Suppose multiplication of row with row or column with column, that cannot be multiplied because the criteria A will not be satisfied. Now let P1 prime is equal to A1 A2, then P2 prime is B1 B2. Then P1 prime and P2 is possible because number of columns in the first A, there are two columns, one row, and here two rows and one column. That's why it is possible. This column, two columns and two rows, multiplication will be possible. Then P1 prime P2 is equal to A1 A2 multiplied by B1 B2 is equal to A1 B1 plus A2 B2. Sum of two vectors, if transposed, it gives the transposition of first vector plus transposition of second vector. Now, if we sum up the two vectors P1 plus P2, and what result we get if we transpose it, so it will be transposition of first vector and transposition of the second vector. Okay. Now, if P1 is equal to A1 A2, elements A1 A2 and P2 B1 B2, then P1 plus P2 prime, that means transpose, will be A1 A2 plus B1 B2 transpose is equal to A1 plus B1 and A2 plus B2. This equal to A1 B1 plus A2 B2. This is equal to A1 A2 plus B1 B2 is equal to P1 prime plus P2 prime. That means transposition of the vector P1 and transposition of plus transposition of vector P2. Okay. Now it also shows that P1 plus P2 transpose multiplied by P1 is equal to P1 transpose plus P2 transpose into P1. This is equal to P1 transpose P1 plus P2 transpose P1. Okay. Now B, P1 plus P2 transpose into P1 plus P2 is equal to P1 transpose P1 plus P2 transpose P1 plus P1 transpose P2 plus P2 transpose P2. Now we can examine. See, if P1 is equal to 2 and 3, P2 is equal to 1 and 4, so we can verify this. We can verify this. So verify the above. This can be considered as a homework for practice. So if the factors, value of the factors are given, elements are given. So these are two column vectors. Now we have to verify that A and B. A is this, P1 plus P2 transpose into P1 is equal to P1 transpose plus P2 transpose into P1 is equal to this. Then P1 plus P2 transpose into P1 plus P2 is equal to this. So by putting values, we can see. Now this sign prime, this is the prime sign. So this is generally used for indicating the transposition of the matrix. In some books you will find it is written like this. Suppose P1T, that means transpose of P1. But if we can put like this also, that means the transposition of the vector P1. So next is vector space. So it is the vector space is nothing but it is a set of vectors. Suppose there are n number of vectors, P1, P2, so on up to n. So we say that it is a vector space. It is generally denoted by R, capital R. Vector space is denoted by capital R. So sum of every two vectors and the product by a scalar P and multiplied by a scalar is in set R. So if we multiply by a scalar K, then it will be in the set R. So sum of two vectors is also in set R. So not only multiplication by scalar but also sum of two vectors will be in set R. Let there are three vectors, suppose P1, P2 and P3. So P1 plus P2 is equal to P4, a new vector in R. Now if we add P4, factor 4 with factor 3, it will be a new vector 5. Now putting values, factor 5 is equal to factor 4 plus factor 3. This is equal to, we have already got factor 4, P1 plus P2, that is factor 1 plus factor 2 plus factor 3. If we repeat, the sum will be in R. So the sum will be in the space R. If the factors are multiplied by a scalar K, the sum will be in R. Suppose the factors are multiplied by a scalar quantity K, so K1 P1 plus K2 P2 plus Km Pm, so will be in the vector space R. Now what is rank? So rank of a matrix is R if and only if it has only one non-singular submatrix of order R. So in a matrix with suppose 4 by 4 or 3 by 3 matrix, there will be several submatrices. If it has only one non-singular submatrix, non-singular we have already discussed. Singular matrix means determinant is 0 and non-singular matrix is determinant is not equal to 0. So if it has only one non-singular submatrix of order R, then the R is the rank of the matrix. Okay. Then norm. Length of a vector is also known as norm. Suppose the length of a vector, we generally do not call it the length of the vector, but a new name, it is called norm for the length of the vector. Suppose P1 prime P1. P1 prime is a transpose of P1 multiplied by P1 is this x1 x2 transpose, and x1 x2 is equal to x1 square plus x2 square. So what is the norm? Norm is written like this. So P1 is equal to under root P1 prime P1. Okay, P1 prime P1. So since it is a square, so P1 will be equal to under root P1 prime P1. P1 is the length or norm of vector. Okay. Then trace. Sum of diagonal elements of a square matrix denoted by some AII is called the trace. Suppose in a matrix, the diagonal elements, right hand side diagonal elements, so if we add them, so that value is known as the trace. So it is denoted as this. This is AII. If it is A11, next A22, then A33, and so on. Only the sum of the diagonal elements. So for M is equal to, it is generally a square matrix, it is, or the square matrix. So if sum of the diagonal elements are met, then this value is known as the trace of the square matrix. So with this, we have completed the field, factor, and vector space. Thank you for watching. So go on watching again, and please share and subscribe so that it reaches the students. Thank you very much.